What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 4, Section 1, Linear Functions. Let's do it. Terry is skiing down a steep hill. Terry's elevation, E of t, in feet after t seconds is given by E of t equals 3,000 minus 70t. Write a complete sentence describing Terry's starting elevation and how it is changing over time. So when we're talking about a starting point, an initial value, for a linear equation, it's always going to be that constant that's just standing alone without a variable. And in that case, that's going to be the 3,000. So we can say that the starting elevation was at 3,000 feet. Okay, and then when we're talking about changing over time, we're now looking at the rate of change, aka the slope. That's the value or the constant in front of the variable. And that's right here. That's that negative 70. And so the elevation is changing by going down 70 feet, and then it's per the time unit. And it said t was representing seconds, so 70 feet per second. Okay, so there's my explanation of the elevation, how it's changing. Boom, done. A boat is 100 miles away from the marina, sailing directly toward it at 10 miles per hour. Write an equation for the distance of the boat from the marina after t hours. So we're going to have a function of distance, right? And that distance is going to be a function of time. Okay, time is going to be that independent variable that's going to affect the distance from the marina. Now, it says we're starting 100 miles away. That's our initial value. That's our y-intercept. So that's the constant out here, 100, okay? And we're adding that to our change, to our slope times the variable. So what is the rate of change? It is 10 miles per hour, but again, it's getting closer by 10 miles per hour, meaning that distance is decreasing. So it should be a negative slope, a negative 10. And then what's my independent variable? It's time, which is t, and t represents hours. And so there you go. There's my function. D of t equals negative 10t plus 100. And you can see that this makes sense logically, right? Like you can imagine in 1 hour, you're going to travel 10 miles, so you're going to be 90 miles away. Plug in 1 here, you get a value of 90. After 2 hours, you'd be 80 miles away. Plug in 2, you should get 80. Verified, boom, done. If a horizontal line has an equation of f of x equals a and a vertical line has the equation x equals a, what is the point of intersection? So if you imagine on an xy coordinate grid, okay, we're saying that a, let's just pretend a is some positive value. It doesn't matter. So if you have a function value or a function equation that is f of x equals a, that would be a on the y-axis, and it would look like this, just like a nice horizontal line. Then if you had x equals a, and again, a is just some positive value, right? It's arbitrary. It looks like it's 3 or something, right? So we could say a here. X equals a would be a vertical line right here, which would stand to reason that that point of intersection of these two lines would be a on the x-axis, a on the y-axis. So the intersection would be a, comma a, boom, done. So the question here is whether this function can be written as a linear function. I would say absolutely yes. And the main reason why is because in this x, right, we don't have an exponent. It's just y equals 3x minus 5. Now, if you wrote it as a function, we could say f of x equals 3x minus 5. There you can have it in kind of that function format. But it is linear by definition because there's no exponent. So yes, boom, done. So the question here is, can this be written as a linear function? And I would say absolutely. So we're going to just isolate that y. 5y equals negative 3x plus 15. Then we're going to divide by 5. We get negative 3/5 x plus 3. And again, basically, what am I doing? I'm putting it into slope-intercept form. And then if we're to represent this as a function, I can again replace that y with f of x equals negative 3/5 x plus 3. There it is as a linear function, which means that the answer is yes, boom, done. So right off the bat with this one, we're not even going to try to turn it into a linear function because that exponent immediately tells me this is going to be a curve. This is not going to be a line. So I would say no, this cannot be written as a linear function. Done. For 13, I would say this definitely can be written as a linear function. We're just going to isolate y. So I'm going to divide everything by 2. I'm going to kind of flip it around. So it's going to be negative x minus 3 divided by 2. You multiply that 2 times the 5. So now it's over 10. And then we can rewrite this and break it up into our nice slope-intercept format. Negative 1/10 times x minus 3 over 10. And again, as a function of x, we could just change it to f of x equals negative 1/10 x minus 3/10. There's my slope right here, negative 1/10. There's my y-intercept, negative 3/10. So we would say, yes, this can be written as a linear function. Done. So for this one, we're meant to determine whether it's increasing or decreasing. So what does that refer to? Increasing or decreasing refers to the slope. It's going to be increasing if the slope is positive, decreasing if the slope is negative. So the slope is this value. It's whatever's multiplying x. So here my slope, or m value, is positive 5. Since it's positive, it is increasing. Boom, done. For this one, it's all about the slope. That is going to determine whether it's increasing or decreasing. And here my slope is whatever constant is multiplying the x value. So here my slope is negative 3. Since it is negative, this function is therefore decreasing. Boom, done. For this function, the slope is whatever is multiplying that x. So the slope is negative 4. Since that slope is a negative value, it means that this function is decreasing. Boom, done. For 21, what is the slope? The slope is that constant multiplying x, which is 1/4. And the important thing is that the slope is positive. So when a slope is positive, it means that the function is increasing. Boom, done. For 23, the slope is this constant multiplying the x value, because it's that in that nice slope-intercept form. So my slope is negative 3/8. Now, because the slope is negative, this function is decreasing. Boom, done. For this question, we're asked to find the slope between 2 points. And the way I like to do the slope calculation is, first, I like to stack the coordinates on top of each other. Then I'm going to draw an arrow to indicate that I'm subtracting down, because the way that we calculate slope is it's the difference of the y values for these coordinates over the difference of the x values. So I'm going to subtract the y values down in that same order for both of those. So I got 5 minus 11 for the y's. And then I got 1 minus 4 for the x's. So 5 minus 11 is negative 6. 1 minus 4 is negative 3. Negative 6 over negative 3 simplifies to a slope of 2. 2 is the winner. Done. So before I start, I like to rewrite the coordinates stacked like this, one on top of the other. And it doesn't matter which one goes on top or on the bottom. It's kind of an arbitrary decision. But then we make sure to subtract down whichever way we set it up, and it's going to work. So first on top, I take the difference of the y's, which is negative 2 minus 6, over the difference of the x's, which is 8 minus 4. Again, subtracting down. This gives me negative 8 on top, positive 4 on the bottom, which simplifies to a slope of negative 2. Boom, done. So to come up with the linear equation here, what we have to decipher is the function notation that's presented here. And what this really means is when x is negative 5, the function value is negative 4. When x is 5, the function value is 2. Now you can see we have two coordinates. And from this, we can generate the slope as well as the equation of the line. So check this out. First, I'm going to calculate the slope by subtracting down. So I'm going to do the y value, difference of the y values, negative 4 minus 2, over the difference of the x values, negative 5 minus 5. That gives me a slope of negative 6 over negative 10, which reduces to negatives cancel out. We simplify to 3/5. And then we can use point slope to come up with the equation of the line. Point slope is really cool. I can choose either point. I'm going to choose 5, 2. Again, arbitrary. So then I have y minus the y1, or whatever this y value of the coordinate is. So y minus 2 equals that slope of 3/5 times x minus that corresponding x value, which is 5. And there's my equation. But to put it into slope-intercept form, that's how it's presented in the answers. All I got to do is do a little simplification. So we're going to distribute. I've got y minus 2 equals 3/5 x minus 3/5 times 5 is 3. Well, it's negative 5, so it's negative 3. And then last step, we're going to add 2 to both sides. Boom, boom. And we get a final answer of, let's put it over here, y equals 3/5 x. Negative 3 plus 2 is negative 1. There's my final answer. Boom, done. So for this one, we're meant to find a linear equation based on these 2 points. So the first thing I'm going to do is I'm going to stack these coordinates on top of each other. Next, I'm going to use that to calculate the slope by subtracting down. So on top, we have the difference of the y values. I go top to bottom. And then I go the difference of the x values, 2 minus 4. Again, top to bottom, just to help me remember the correct ordering. And again, if I flip the coordinates, it's fine. It's just you have to stay consistent with the subtraction. So now we have -6 over -2, which simplifies to 3. So we got a slope of 3. Now we're going to do point slope formula. So I'm going to arbitrarily choose this coordinate. Again, it would work with this one as well. But we're going to start with y minus the y value of that coordinate, which is 4, equals slope times x minus the x value of that same coordinate. And now we have a nice linear equation. Now, they didn't say this, but in the answers, they have it in slope-intercept form. So let's convert it. So we're going to go ahead and distribute like so. 3x minus 6 equals y minus 4. Last but not least, add 4 to both sides. Y equals 3x. -6 plus 4 is -2. Here is your final equation. Boom, done. To find the linear equation, first I'm going to stack the coordinates so I can calculate the slope. Next, I'm going to subtract down, so we do the difference of the y's on top, right? 4 minus 2 first, and then over the difference of the x's, -1 minus 5. 4 minus 2 is 2, -1 minus 5 is -6, and that simplifies to -1/3. So there's my slope. Now I'm going to use point slope. Let's choose this one because there's no negatives, just a personal preference. So I got y minus the y value up there, which is 2, equals -1/3, my slope, times x minus that corresponding x value, which is 5, like so. So technically, this is the linear equation, but in the answers, they have it in slope-intercept form. So let's go ahead and distribute and simplify. So I got y minus 2 equals -1/3 x, and then -1/3 times -5 is +5/3. Last but not least, we're going to add 2 to both sides. And remember, when we're adding 2 to that mixed number, we can think about it as 2 over 1, or 4 over 2, or in this case, 6 over 3. So 6 over 3 plus 5 over 3 gives us an improper fraction, of 11, right? 6 plus 5 is 11 over 3. So there's our final answer for the linear equation. Y equals -1/3 x plus 11/3. Boom, done. So for this one, I'm going to start off by once again stacking the coordinates, and I'm just going to put the x-intercept on top, but that's arbitrary. Then to calculate the slope, I'm going to subtract the y's on top, 0 minus -3 over -2 minus 0. And that double negative turns into a plus, so we have 3 over -2 for the slope. Now I'm going to take it straight to slope-intercept form, and the reason why I'm going to do that is because they gave me the y-intercept, so that's really nice. So I can just say y equals -3 over 2, the slope, times x, and then plus that y-intercept, but it's a negative, so I'm going to make it -3. There's your answer. Boom, done. So to determine if these are parallel, perpendicular, or neither, what I'm going to do is I'm going to put both of them in slope-intercept form, meaning I'm going to isolate y. So for the first one, I'm going to start by subtracting 4x from both sides, and then I'm going to divide by -7, and I get y equals +4/7, because it's a -4 divided by -7, so +4/7 x minus 10 over 7. And then for this one, we're going to start here first. We're going to say 4y equals -7x plus 1, so I subtracted 7x. Then we're going to divide everything by 4, so I'm going to put it here so we can see it. Y equals -7/4 x plus 1 over 4. So we notice the slopes are not the same, so they're definitely not parallel, definitely not the same line, but they do have a relationship, and the relationship is that they are opposite reciprocals of each other. So for example, if you have one that's 1/3, one that's -3 over 1, they're opposite, meaning one's positive, one's negative, and they're reciprocals, 1 over 3 versus 3 over 1. So in our case up here, we've got 4 over 7, -7 over 4, which means these two lines are perpendicular. Boom, done. For this one, once again, I'm going to put each one in slope-intercept form. So let's start with this one. We're going to subtract both sides by 4x, so I get -4x plus 12. Then I'm going to divide by 3. Y equals -4/3 x plus 12 divided by 3, which is 4. For this one, we're going to first do it here. Actually, this one's great because we already got the 8x on the other side. I'm just going to straight divide by -6. So 8 divided by -6 is -8/6, but I can reduce that to -4/3. I'm going to go ahead and do that in one step. Then 1 divided by -6 is -1/6. So check this out. They have a different y-intercept, but they have the same slope. Both have a slope of -4/3, which means these lines are parallel. Boom, done. For this one, we're meant to find the x and y-intercepts of each equation. So the x-intercept is the value of y when, the value of x when y equals 0. And the y-intercept is the value of y when x equals 0. So this is really helpful because now to find each of these values, I can just plug and chug. So when I say y, right, really, this is a function. So the function value, f of x value, is y. So check it out. I'm going to plug 0 in here. And I got 0 equals negative x plus 2. Subtract 2 from both sides. Negative x equals negative 2. X equals 2. Here is my x-intercept. Now what about my y-intercept? I'm going to plug 0 in for x, right? So f of x now equals 0 plus 2, which is just 2. So then my y-intercept is 0, 2. Boom, done. So for this one, once again, we start off on the assumption that a y-intercept is when x equals 0 and the x-intercept is when y equals 0. So we're going to start here. We're going to plug and chug. So plug 0 in for x. We get h of x equals 0 times 3, which is 0, minus 5. That is just negative 5. So there's my y-intercept. What about my x-intercept? Now I plug 0 in for y, aka the function value. So 0 equals 3x minus 5. We're going to add 5 to both sides to isolate x, and we're going to divide by 3 like so. X equals 5 over 3. There's your x-intercept. There's your y-intercept. Boom, done. So first, to find the y-intercept, I'm going to plug 0 in for x because x is 0 at the y-intercept. Plug that in. This term basically goes away. And then I have 5y equals 20. Divide by 5. Y equals 4. So there's my y-intercept. Now, what about for the x-intercept? For the x-intercept, I'm plugging 0 in for y. So that kind of goes away. And then I have negative 2x plus 0 equals 20. Divide both sides by negative 2. X equals negative 10. Plug it in, negative 10. Y-intercept 0, 4. X-intercept negative 10, 0. Boom, done. So for this one, we have information about points for each of these two lines. So what we should do to figure out the relationship of the lines is calculate the slope first and foremost. So again, I'm going to stack the coordinates. So I got 0, 6, and I've got 3, negative 24. And we're going to subtract down, right, to get the slope. So I have 6 minus negative 24 for the difference of the y's over 0 minus 3 for the difference of the x's. That becomes a plus, double negative. So 6 plus 24 is 30. 0 minus 3 is negative 3. So this has a slope of negative 10. Okay, that's for line 1. What about line 2? Again, let's stack the coordinates. Negative 1, 19, 8, negative 71. And we're going to subtract down. So we got 19 minus negative 71 over negative 1 minus 8. 19, that minus negative 71, that becomes a plus. Now we have 90 over negative 1 minus 8 is negative 9. This also simplifies to negative 10. Now, when the two lines have the same slope, but we don't know anything else, there is a possibility that it could be the same line, right? They could be 100% exactly the same. Excluding that scenario, assuming they're not the same line, but they do indeed have the same slope, this means that the lines are indeed parallel. Boom, done. So for this one, we're going to start by stacking the coordinates and calculating the slope of each line. So we're going to subtract down. Difference of the y's on top, 3 minus negative 1 over 2 minus 4. That becomes a plus, right? Double negative is a plus. So we get 4 over negative 2, which is a slope of negative 2. Okay, and then this one, let's stack them again. So we got 6, 3 over 8, 5. And then we're going to subtract down. So we do the difference of the y's on top, 3 minus 5 over 6 minus 8 on the bottom. Okay, and that gives me negative 2 over negative 2, which gives me a slope of 1. When the slopes are different, okay, but they're not opposite reciprocals, which they're not here, right? This is a slope of negative 2. This is a slope of 1. So not opposite reciprocals, just straight up different. These lines are neither parallel nor perpendicular. So we say neither. They just intersect. Boom, done. For this one, once again, I'm going to stack the coordinates and calculate the slopes. We got 2, 5, 5, negative 1. And we're going to subtract down. So again, I got 5 minus negative 1, the difference of the y's on top. 2 minus 5, the difference of the x's on the bottom. That becomes a plus. 5 plus 1 is 6 over negative 3, aka a slope of negative 2. What about this one? So we're going to stack the coordinates again. Negative 3, 7, 3, negative 5, and subtract down. So we got 7 minus negative 5 over negative 3 minus 3. So that becomes a plus. So then we got 12 over negative 6, which is also negative 2. So again, if two lines have the same slope, they are likely parallel. There's only one exception, and that's if the y-intercepts are the same, meaning they're the exact same line. But these two are not the same. They're not the same line, but they do have the same slope, which means these two are parallel. Boom, done. When we're trying to get an equation that's parallel to this and has this point, I'm thinking point slope, right? We got the slope, we got a point. Because if they say parallel, it means it has the same slope. And what's my slope when y equals mx plus b? It's that number in front of the x variable. So using point slope, y minus the y value of this coordinate, which is 9, equals slope, which we said is 3, times x minus the x value of this same point. So this is enough to actually be the final equation. But to put it into slope-intercept form, just like they have it in the answers, we're going to distribute and simplify. So y minus 9 equals 3x minus 12. Last but not least, we're going to add 9 to both sides. Boom, boom. Y equals 3x minus 3 is the winning answer. Boom, done. Now we want to write an equation that's of a line what is perpendicular to this and passes through this. So perpendicular means opposite reciprocal slope. Right here we have a slope of 3. Opposite reciprocal of that is negative 1/3. So there's my slope, there's my point. Let's use point slope. So we got y minus the y value, which is 1, right, equals my slope, negative 1/3, times x minus the corresponding x value. But since the variable in question here is actually t, we're going to say t minus that 3 value. Now to put in a slope-intercept form, we're going to distribute y minus 1 equals negative 1/3 t. Negative 1/3 times negative 3 is positive 1. Last but not least, we're going to add 1, and we get y equals negative 1/3 t plus 2 for the win. Done. So for this line, we're meant to identify the slope, right? And what is slope? It's rise over run, but this line is completely flat. There is no rise, meaning the rise is 0, aka the slope is 0. That makes sense, right? Flat ground, flat land has a slope of 0. It's completely flat. So here the slope is 0. Boom, done. So we want to come up with an equation for this line. So we need two components to get a nice equation. First, I need to know the y-intercept, which I can see right there. It's equal to 5 or 0, 5 in coordinate format. Next, I need to figure out the slope of this line. Well, I've got another nice, easily identifiable point, the x-intercept. And so now I can look at the rise over run going from one point to the next. So I'm going down 5, right? And I'm going to the right or across by positive 4. So my slope is negative 5 over 4. And now to put this into an equation format, it's y equals my slope, negative 5/4 x, plus my y-intercept, which is 5. There's the answer. Done. So for this line, to once again get the equation, we need the y-intercept, which I can see right there is negative 1. And then we need the slope, which I'm going to choose a second point, which this one looks nice. It's easy to identify, 1, 2. And then we're going to look at the rise over the run. So to go from one point to the next, I'm going up by 3 and over by 1, both positive. So 3 over 1, aka 3. Now in slope-intercept form, y equals the slope, 3 times x, plus that y-intercept, in this case, minus 1, because it's negative 1. There's the answer. Boom, done. So for this line, we see that it is a horizontal line. And for horizontal lines, the equation is simply y equals whatever the constant is that they're at, right? So it's always consistently at one level, at one y value. By the way, just on a side note, a vertical line would be x equals whatever that one singular value is that x will always be on. So here, the y value looks like negative 2.5. And that's it. That's my equation of the line. It makes sense because the slope for a horizontal line is 0. So you could think about it like there could be a 0x plus negative 2.5, but we don't write it because 0 times x is just 0. So there's the winning answer. Boom, done. So for this question, we're meant to identify which line matches up with f of x, which has a slope of negative 3 and a y-intercept of negative 1. So here's negative 1. So here's where I see 3 lines hitting negative 1. So it could be any of these 3. It's either D, E, or F. But then the question is, which one has a slope of negative 3, meaning going down by 3 and then going over by 1. That's negative 3 over 1, a slope of negative 3. Well, look at that. It's got to be F. You see, it's come over by 1. So the answer for 65 is F. Boom, done. For 67, the question is which line is f of x equal to 2, which is the same thing basically as y equals 2. And what I mentioned in previous explanation is that when it's y equals a constant, it's a horizontal line. There's only one horizontal line here, and there's only one position right at 2, by the way, which this needs to be positioned at 2. Y should always be 2, right? So obviously the answer for 67 must be C. Boom, done. For f of x equals 3x plus 2, we need a y-intercept of 2, which is right here. So it could be either be C, A, or B. And it's got to have a slope of 3, meaning it's got to go up by 1, 2, 3, and then over by just 1. That's a nice slope of 3 over 1, aka 3, which obviously matches up with A. So A is the winner. Boom, done. To sketch a line from 2 points like this, all I'm going to do is I'm going to plot the points and then we're going to connect the dots. So we have a point at -2, 0. So you're -2 and 0 on the y-axis. So right there on the x, or on the, going up and down for the y. So right there on the x-axis, and then 0, 4, y-intercept right here. 0 and 4 going up on the y values. And then now we're going to connect the dots. And there's the final graph. Boom, done. So for this one, we have a y-intercept of 0, 3, which I'm going to plot right here, right on that nice y-axis. And then it's got a slope of 2/5, which is a rise of 2, meaning go up by 2, and then a run of 5, meaning going to the right by 5. So just by applying the slope, we can get a second point right there. I could do it again in the other direction too, by the way. 2/5 positive is the same as -2, -5. So I could go down by 2 and left by 5, and you see that lines up as well. Now, as we connect the dots, we get the full line. There it is. Boom, done. For this one, we got 2 points, -3, -4. So I go left 3, down 4. Boom, there's point number 1. And then we got 3, 0, which is an x-intercept, 3, 0. And now we just connect the dots. And as you can see, here is the final line. Just for fun, I can show you it's got a nice slope of up 2 over 3, meaning 2/3. That's it. Boom, done. Sketching a graph of a linear equation or linear function when it's in slope-intercept form is really nice because the protocol is pretty standard. We start with the y-intercept, that's that value right here, and we plot that directly on the y-axis, this y-intercept. Then we apply the slope. But by the way, that slope is not just -3. Remember, it's always rise over run. So if it's just an integer just like this, we imagine that underneath it is a 1, always. So we got a slope of -3 over 1, which means to get to the next point, we go down by 3 over by 1. Just one more point just for fun, down by 3 over by 1. And now we connect the dots. And there's our final line for this equation. Boom, done. To graph this linear equation, we're going to start with that y-intercept right there, which is -3. And then we're going to apply that nice slope of 2/3, which means a rise of 2, a run of 3. A rise of 2, a run of 3. Then we're going to connect the dots like so. There is your line. Boom, done. So for this one, our y-intercept, or kind of in this case, p-intercept, because the function, it's p of t, but we can still consider a y-intercept equivalent, is the constant by itself. Even though it's in front, it's still that constant, meaning it's still the y-intercept of -2. And then we're going to apply that slope in front of the variable. That's 3, or really 3 over 1. So that means to get to the next point, we're going up by 3, over by 1, up by 3, over by 1. And as we connect the dots, there's the final line. Boom, done. So for this one, it simply says x equals -2. And you might be wondering, where's the y? Well, if you recall, this is what a line that is vertical looks like. Okay, it's just x always equals -2. So think about it like this. Where does x equal -2? How about right here? Well, how about right here? X is still -2. How about right here? X is still -2. How about this point? So you see it's all those points, all the collection of points where x is -2, and then you connect the dots to get that nice vertical line. Boom, done. So for this one, we're meant to give the equation of the line. And if you recall, a horizontal line is just y equals a constant. So the question is, what is that constant? Well, it looks like the y value is perpetually 3 on this line, right? It's always 3. Hence, the equation of the line is y equals 3. Boom, done. Now for this line, this is a vertical line. As we've mentioned before in previous explanations, a vertical line is always x equals some constant. There's no y. Now, how do we determine what that constant is? Well, what is the x value in all of these instances on the line? It's always -3, right? -3, -3, -3. Therefore, the equation for the line is x equals -3. Boom, done. So for number 89, the first question is, could this represent a linear function? So to answer that, we need to make sure that the rate of change is consistent throughout. So if you notice for all the x values, we're going up by 5, going up by 5, going up by 5, and that's good. For all of the corresponding y values or g values, function values, It looks like it's going down by 15, right? 5 to negative 10 is negative 15. Going down by 15, and again going down by 15. This looks good. This looks like this definitely could be a linear equation. So my question then is, what is the slope? What is the rate of change? Well, it's the difference of the y values over the x values. We kind of calculated that, right? You can think about it. Negative 10 minus 5 is negative 15. 5 minus 0 is 5. So we already got those differences. I put one on top of the other. Negative 15 over 5, which simplifies to a slope or rate of change of negative 3. Then we can take that with the y, or in this case, g-intercept, right? It's the y-intercept occurs when x equals 0. So we got everything we need for slope-intercept form. We could say g of x equals the slope, negative 3, times my x variable. And then we add that y-intercept plus the y-intercept of 5. There is my function. Boom, done. So first, to determine whether or not this can be a linear function, I'm going to look at the changes here. Every time it's going up by 5, it's going up by 5, it's going up by 5 for the x's. Now let's look at the y's. It's going up by 25, right? 25 plus negative 5 is 20. Up by 25 again, up by 25 again. So look at that. The rate of change, the ratio, I should say, between the y's and the x's is consistent. That's a constant rate of change, and that's what a linear equation or linear function is all about. So we know that this is indeed linear. Now we need the two components. We need the y-intercept and we need the slope. Well, my y-intercept is right here. When x equals 0, that's the y-intercept. That's the value of the function, which is negative 5. So we can say my y-intercept, or b, is negative 5. What about the slope? The slope is the rate of change. It's the difference of the y values over the difference of the x values. We already calculated those. So it's 25 over 5, which simplifies to a nice slope of 5. Now to get the final equation in slope-intercept form, we put my slope next to the x, 5x, and then plus the y-intercept, which is negative 5. So I can just say minus 5 or plus negative 5. Either way, there is the winning function. Boom, done. So the first question is this possibly a linear function? So we're going to look at all the changes of the x's on top. It's going up by 2 every time. And then the corresponding changes of the function value, which here it looks like it's going down by 25, right? 6 minus 25 is negative 19. Negative 19, again, minus 25 is negative 44. And again, minus 25. So this is looking promising, like this will indeed be a linear function, constant rate of change. That rate of change is the change in the y's, negative 25, over the changes in the x, positive 2. Again, rise over run. So there's my slope. What about my y-intercept? Well, the y-intercept occurs when x equals 0. Look at this. It's right there. My y-intercept is positive 6, which means my final linear function could be my slope, negative 25 over 2 times x plus the y-intercept plus 6. There is the winning answer. Boom, done. For this one, let's first check the rate of change for the x's. Each one is going up by 2. And for the y's, everything is going up by 20, right? Negative 4 plus 20 is 16. Again, 20. And again, 20. So this is promising that this is indeed a linear function because we need a consistent or constant rate of change. And my rate of change is rise over run, change in the y's over change in the x's. And every time it's 20 to 22. So it's 20 over 2, which means we have a nice slope of 10. Okay, so there's my slope. It's a consistent slope. And then what about my y-intercept? That's when x equals 0. Well, in this case, we don't know what the y-intercept is. So I can't go straight to slope-intercept form. Instead, I'm going to go back to point slope. I'm going to choose an arbitrary point to use for point slope. And I'm going to choose 416 because it's a little easier, I feel like, to get it correct when both values are positive. So I've got y minus the function value, or the y value, which is 16, equals my slope, 10, times x minus the corresponding x value, which is 4. Then to get it into slope-intercept form, we're going to distribute. Y minus 16 equals 10x minus 40. Then last but not least, I'm going to add 16 to both sides. Okay, now when I write the final form, since it's a linear function, I'm not going to write it with the y. I'm going to turn it back into f of x. So I got f of x equals 10x, right? That's the slope. And then minus negative 40 plus 16 is negative 24. So that is the y-intercept, negative 24, if it went back to 0. And there is the final answer. Boom, done. So for this one, it does mention that we can use technology, aka a calculator, but I'm going to show you how to do this by hand because the only way that technology really helps is just because the numbers are a little funny with the decimals, but we can do this no problem. So first, I need to get the slope. And remember, this just represents a coordinate in function notation, meaning for an input value of 0.1, we get an output or function value of 11.5. Likewise, this is a coordinate of 0.4, negative 5.9. Now, first we have to calculate the slope, and I like to stack them so I remember to subtract down. So I get the difference of the y's on top, 11.5 minus negative 5.9, over the difference of the x's on the bottom, 0.1 minus 0.4. Double negative turns into a plus. 11 plus 5.9, or 11 plus 5 is 16. Those two make it 17.4. Again, you can use a calculator on this to verify. And then on the bottom, we get negative 0.3. Now, if we divide this out and simplify via long division, 3 goes into 17 5 times. That's 15. Bring down the 4. 3 goes into 24 8 times. So this actually simplifies to a nice slope of negative 58. Now, to get to the final distance of getting this in slope-intercept form, we need to use point slope. So again, I'm going to arbitrarily choose this point, right? 0.1, 11.5. So it's y minus the y value, 11.5, equals my slope, negative 58, times x minus that corresponding x value of 0.1. And then we're going to distribute. We get y minus 11.5 equals negative 58x. And then negative 58 times negative 0.1 is positive 5.8. Last but not least, we're going to add 11.5, add 11.5, and we get y equals negative 58x plus, and then 11 plus 5 is 16, plus 1.3 is 17.3. Now, in final function format, because it said f is a linear function, it should be written as f of x instead of y, same thing. F of x equals negative 58x plus 17.3 for the win. Boom, done. This one says graph the function f on a domain of negative 10 to 10. That's the domain of the x values. And this is your function. I think they're missing a parentheses here. F of x equals 2500x plus 4000. Check it out. So using Desmos, I plugged this function in and I made the domain from negative 10 to 10, but I modified the y value so you could really see the curve and the slope of this line. And that's kind of it. You see it's got that nice y-intercept of 4,000, which we can see there. And now you can really see that slope of 2,500, right? It's going up 2,500 over 1, up 2,500 over 1, and so on and so forth. Boom, done. So for this one, I'm actually going to do it a little bit in reverse. I'm going to do B first, and I'm going to show you that I think this is the easier way to do it. So first of all, they're telling us that this is a linear function, right? So we can easily calculate the slope by looking at the changes in the x, in this case p values, which is going up by 0.3, and the corresponding changes in the y or q values, which is going up by 300. And then we take 300 over 0.3, and we get our slope. Move that decimal over, add a 0. 3,000 divided by 3 is a slope of 1,000. And now we can try and figure out the equation for this, and then we can use that to get our values for a and b. So now I can come up with the equation in point slope format. So I can say q, which is really like my y here, minus the corresponding y value, which is 400, equals my nice slope of 1,000 times p minus that corresponding p value, which is 0.5. So I'm going to distribute this to put it into slope-intercept form, and I've got q equals 1,000 p, and then 1,000 times negative 1/2 is negative 500, right? Half of 1,000 is 500, with the negative is negative 500, but I'm adding 400 to it. So negative 500 plus 400 is negative 100. So I kind of combined those steps. Hope that wasn't too quick. But there's your equation. And by the way, you could still use this equation if you wanted to. But this one's going to be really nice. Now I want to know what's the value of Q, aka A, when P is 12. So now we're starting to do part A. So taking 12 and plugging it in for P, I get 12 times 1,000, which is 12,000 minus 100, which is going to give me 11,900 for A. Now, what about B? So for B, they're giving us the Q value of 1,000,000. So I have to plug that in for Q right here. And then I have to solve for P. So we're going to do that up top. We got 1,000,000 equals 1,000 P minus 100. So I'm going to add 100 to both sides. 1,100,000 equals 1,000 P, and then we're going to divide both sides by 1,000 like so. Again, you can use a calculator if you want, but check this out. Dividing by 1,000, you just move the decimal over once, twice, 3 times. So my answer for B is 1,000.1. There's the winning answer. Boom, done. For this question, we're meant to graph a function that has a slope of 75 and a y-intercept of negative 22.5 on this domain. Now, let's first create that equation. So we've got f of x equals a slope of 75 minus that y-intercept of 22.5. And now we're going to go and plug it into Desmos. All right, so here's the equation of the line in Desmos. There's the function 75x minus 22.5. As you can see here, it's got that nice slope. And then I wanted to label these 2 points at negative 0.1, which is at negative 0.1, negative 30, and positive 0.1, which is at 0.1, comma, negative 15. There's your answer. Boom, done. Find the value of x if a linear function goes through the following points and has the following slope. So what I'm immediately going to do is I'm going to take this coordinate, I'm going to stack it, as I always do, right? X, comma 2, negative 4, comma 6. I'm going to calculate the slope by subtracting down. So I got the difference of the y values on top over the difference of the x values on the bottom. And guess what? I already know what this is supposed to equal. This is supposed to equal 3. Now I got a beautiful equation that I can solve for x. So 2 minus 6 on top is negative 4. X minus negative 4 is the same as x plus 4. Now I'm going to multiply out by that denominator. So negative 4 equals x plus 4 times 3, which if I distribute that becomes 3x plus 3 times 4, which is 12. Then I'm going to minus 12, I'm isolating, and I get 3x equals negative 16. Last but not least, divide by 3, and x therefore equals negative 16 thirds for the win. Boom, done. Find the equation of the line that passes through the following points. So first and foremost, we need to calculate the slope. So I'm going to stack these coordinates, and we're going to subtract down. So we do the difference of the y values first over the difference of the x values. Again, top minus bottom. Well, a minus a is 0, okay? And then b minus 1, because I'm going to distribute that minus, becomes negative 1. Negative 1 over 0, that's indeterminate. That's undefined. What does that mean when we have an undefined slope? That is a vertical line, meaning the equation for the line is simply x equals a constant. So it's whatever constant in terms of the x value that this line is continuously going through. Well, guess what? I only know one possible x value. That's a. In both of these coordinates, it's a. It's a. Therefore, the equation of the line is x equals a. Boom, done. So for this one, we're going to first start by stacking the coordinates and calculating the slope. So we're going to subtract down. First on top, we got 0 minus d. On the bottom, we have a minus c. So here's my slope, which is negative d over a minus c. So there's my slope. Now I'd love the y-intercept. I don't have the y-intercept, unfortunately. So I'm going to go to point slope. And I'm going to use the top coordinate because I feel like it's going to be easier. Because it's going to be y minus that corresponding value, which is 0. But y minus 0 is just y. So that's nice. Equals my slope, negative d over a minus c, times x minus that corresponding x value, which is a. Now to get this into final slope-intercept form, we're going to distribute, and I get y equals negative d over a minus c x minus, actually that'll become plus because the negative and the negative cancel out, and then we got d times a over a minus c. Just as an aside, I want to let you know that if you do look in the back of the book, they give a similar but slightly different answer. So I want to show you where they came up with their answer. Instead, they have c minus a in the denominator, and that's fine. You can make this c over a by factoring out a negative 1, right? If you factor out a negative 1 from the denominator, it becomes c minus a, and then you can make that d in the numerator positive. So this is an alternative answer, just if you're wondering if like, hey, why does this not match with the back of the book? It's equivalent, but it'd be positive d over c minus a x, and then it's negative ad over c minus a. Once again, these two are equivalent, so both should be correct, but this is how they got the answer in the back of the book. Boom, done. So for this one, we're trying to find an equation of a line perpendicular to this line. Well, perpendicular means the slope is going to be the opposite reciprocal. So right now, it's negative 0.01, which is the same as negative 1 over 100. What's the opposite reciprocal? Well, it's going to be positive, and it's going to be 100 over 1, so a slope of positive 100. And now we got the slope. Now we got a point. Let's use point slope. So it's y minus the corresponding y value, which is 2, equals slope times x minus that corresponding x value, which is 1. Now to put it into slope-intercept form, we're going to distribute y minus 2 equals 100, x minus 100. Last but not least, we're going to add 2 to both sides. Y equals 100x. Negative 100 plus 2 is negative 98 for the win. Boom, done. So this question asks, where is f of x larger than g of x and vice versa? Now, what you can see, first of all, as we observe, is we see that this is a positive slope, this is a negative slope. That means f of x is going down and g of x is going up. So it's kind of like, just as a rough sketch, here would be f of x, right? And here would be g of x, positive slope. So you can see that wherever they intersect, to the right of that, g of x is going to be bigger. To the left of that, f of x is going to be bigger. So let's first see where they intersect. Let's set these two functions equal to each other. Now I'm going to solve for x. I'm going to add 0.1x to both sides, like so, while simultaneously minusing 0.1 from both sides. And then I get 199.9 equals 20.1x. And then we're going to divide both sides by 20.1. Divide both sides by 20.1. And this is going to give us a non-repeating decimal. It's going to go on and on forever. But instead, we can just simplify this down to be an improper fraction of 199.9 over 20.1, or multiply top and bottom by 10, and we get 1999 over 201. So again, that's this point right here. That's the x value. The x value of this point is 199 over 201. So we say, where is f of x greater than g of x? Again, f of x is this negative slope, meaning it's bigger before this. So it's bigger than that when x is less than 1999 over 201. Whereas g of x greater, that's to the right of that point. So that's when x is greater than 1999 over 201. Boom, done. So in this one, it says a gym membership with 2 training sessions costs $125 and 5 training sessions cost $260. What is the cost per session? What are they asking? They're asking the slope, cost per something. Okay, well, I can quickly turn this into 2 nice coordinates. With 2 training sessions, I spend $125. For 5 training sessions, I spend $260. Well, guess what? I can do the slope now. Subtract down. We got 125, difference of the y's, 125 minus 260. Over 2, the difference of the x is 2 minus 5. So 125 minus 260, what is that? Negative 135 over negative 3. That happens to be divisible by negative 3. That simplifies to positive 45. So the cost per session is $45. Boom, done. So for this one, it says the phone company charges services according to this formula. This is the cost, where n is the number of minutes talked. C is not the cost, it's the monthly charge, excuse me. Maybe you can say cost, that's a similar idea. So they said, interpret the rate of change and the initial value. Initial value is my constant, that's standalone. What we can say that initial value is that no matter if you talk 0 minutes, your baseline paying $24 per month. So that's the baseline monthly charge. And then what's the rate of change? The rate of change is next to the variable. That's 0.1, or we can say that's 10 cents, right? Or $0.1. And we can say that you're charged 10 cents or $0.1 for every minute that you talk. So there's your interpretation. Boom, done. So here it says the population in 1960 was 287,500. And then in 1989, the population was 275,900. And it says calculate the rate of growth of the population. Now, this doesn't say this, but we're going to assume that this is linear because we're in the section about linear functions. So we're going to assume linear meaning constant rate of change. So now that I've got this written into nice coordinate format, I'm going to do my normal thing. I'm going to subtract down, calculate my slope, aka rate of change. So we've got the difference of the y's, 287,500 minus 275,900 over 1960 minus 1989. So on top, we've got positive 11,600. On the bottom, we have negative 29. When you divide these two, believe it or not, it goes in exactly 400 times. So my slope is negative 400. So how we can write that or make a statement about the population change is that the population, this is again a rate of change. This is negative 400 per year. So we can say the population is decreasing by 400 people per year. That's a good way to state the slope. Boom, done. Suppose that average annual income in dollars for the years 1990 through 1999 is given by the linear function, this guy, where x is the number of years after 1990. Which of the following interprets the slope in the context of the problem? So before we read the choices, what is the slope? Well, the y-intercept is this constant by itself, and the slope is 1,054. So that's very important. So we know that any correct answer needs to be talking about this 1,054. And by the way, this is average annual income. So this is changes in income per unit of x, and x is in years. So what this looks like, since it's a positive slope, it looks like the average annual income is going up by $1,054 each and every year. So A is dealing with the y-intercept, so that's out, and D has this y-intercept again, which actually wouldn't be the end of 1999. That's when x is 0, meaning in 1990, that's the average annual income. Now we come to B and C, and they both are talking about this 1,054. But as I mentioned, that's 1,054 per year. That's the rate of change. It's the change in Y per 1 unit of the change in the X value, in this case, change in years. So it's not going up by a total of 1,054. Average annual income, each year it's changing by 1,054, which means C is the winner. Boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.